Now we can move on to binding the geometry to the generated rig. But first, I'll group the objects. I create a common group by pressing Ctrl G, which I name as Dick Rig Don't Move. Typically, the parent group cannot be moved. Its attributes can be locked, but I won't do that now. Just keep in mind that the rig can be manipulated through controllers only. Then I create a group for geometry. I'll call it Geometry GRP. I'll add all objects related to the character's geometry to it. And after, I'll add guides and the generated rig to the common group with the geometry. I prefer to store guides together with the rig. They don't affect performance in any way. But if something happens, you can quickly correct it and update the rig. Except that to rebuild a group of guides, you need to drag and drop them to the root of the project. Otherwise, mgear will show an error. Don't forget to save regularly. I also recommend you to set up autosave so you don't lose the work you've done. Now I'll attach the body of the character to the joints of the rig with the skin deformer. At first, I'll select all the joints by right-clicking on Set Dick Deformers GRP, and I'll choose Select Members. As you can see, all the joints are selected. Then I press Ctrl and add the character's body to the selection. And in the section of rigging from the skin menu, I'll select the property of the command Bind Skin. The option Bind To defines exactly where the binding will take place. So I set Selected Joints to obviously bind to the selected joints. The Bind Method option defines a method for automatically calculating joint weights. Here you can experiment and choose the one that gives the best results. I'll choose Geodesic Voxel. It gives good results by distributing the influence of joints over the volume within the geometry. The skinning mode defines the skinning method. It can be classic linear or dual quaternion. Each of them has its own advantages and disadvantages. The weight blended method allows you to use both methods simultaneously, indicating where exactly each one of them will work. I'll draw a map of the weights by geometry. I won't dwell on the nuances of their work. I suggest you experiment on your own. I almost always use the classical linear skinning, so I'll do the same now. I also disable the Remove Unused Influences option, so that no joints are excluded from the skin deformer. It'll help avoid some problems with saving and loading the weights in the future. The Fall-Off option refers to the geodesic voxel calculation method and determines how rigid the deformations will be. 1 is the maximum stiffness, 0 is the minimum. You can experiment with it, as with the resolution parameter, which determines the quality of the calculation. So the higher it is, the better it is. I'll leave everything at the default and press Bind Skin to bind the geometry. We can see that the body follows the rig now. If you want to apply a skin with other original settings, you need to delete the previous deformer. You can do this, for example, by selecting the geometry and applying the Unbind Skin command with Delete History mode. In the same way, I'll bind the hair, eyebrows, glasses, teeth, and shoes. Pay attention that the geodesic voxel method doesn't work for glasses. As soon as the points are bound in this way, they disappear. So I remove the skin and probably calculate the weights with the default closest distance method. Then I'll attach the teeth and shoes. Basically, you can bind geometry only to those joints that should potentially affect it. For example, you can bind only hair and head joints. But I prefer to bind the geometry to all joints of the rig at once to avoid wasting time looking for the right joints in the scene. In order to bind clothes that are worn over the body, it would be more handy to use a deformer that allows you to deform the object with the surface of another object. In that case, you'll have to adjust the deformations only on the body, and the clothes will repeat all the shape changes automatically. Whereas if you deform clothes with skin deformer, the weights will have to be adjusted to make the deformations the same on the body and clothes. Otherwise, the clothes will flow through the body. You can use the wrap deformer for this, or the more universal proximity wrap that Maya has in the 2020 version. You can also use the deformer that comes with M-Gear, which is called CV wrap. This is probably the fastest of the above, so I'll use it. To do this, you have to first select the clothes, then the body, and select the CV wrap from the Deform menu. I'll leave the default settings. The singlet now follows the body, and in the same way, we see the hidden CV wrap 1 base object appear in the outliner. As for many other deformers, Maya keeps a static copy of the geometry to which the binding is done. Now I repeat these steps for the pants, belt, and body hair. Obviously, the clothing and the body must be separate objects for this deformation approach. So before you start skinning, check if the model meets these requirements. Keep in mind that if you want to achieve a better deformation, the automatic skinning will probably have to be edited manually. You can do this with the Paint Skin Weights tool. To reach it, you can, for example, select the geometry and choose the tool Paint Skin Weights from the Skin menu. For convenience, I'll show how to work with it on such a simple scene, where I created a simple polygonal strip with 3 deforming joints with a short animation. The Influences field of Paint Skin Weights tool shows a list of all joints that influence the geometry. Each joint has a weight which determines its degree of influence on the point. We can see that Maya displays the weight of the joint by color. If the weight is equal to 1, which corresponds to white with the current display settings, then the geometry point will completely repeat the transformation of the joint relative to the neutral position in which the skin deformer was created, the so-called bind of pose. But if the weight of the joint is 0, which corresponds to the color black, then the joint has no influence on this point. Each point can be influenced by several joints at the same time, and their influence will be distributed depending on the weight. Thus, weights of joints are normalized. It means that the total weight of all joints influenced in the point must be equal to 1. This means that if I add weight to a joint for a point, the weights of the other joints influenced in the point will decrease, and vice versa. So if you want to reduce the influence of a joint on a point, you should add the influence of another joint. You can edit weights by drawing on the geometry with a brush in different modes. You can completely replace the weight value in Replace mode. You can add some value in Add mode. You can scale in Scale mode. And you can smooth out the weight by distributing it between adjacent points. You can also smooth the weights by pressing Shift in any mode. If you want to change the size of the brush, it changes with the left mouse button, while pressing the B key. Also, you can apply any mode to the whole geometry by clicking on the Flood button. You can also select points of the geometry and then apply the weight change only on them. I usually prefer to specify 100% of the influence of the joints to the active points first, and then smooth out the weights. For a more fine adjustment, I usually add the influence of the desired joints on certain points. It's convenient to select the active joint in the viewport by right-clicking the joint and dragging. Actually, I recommend using a handier tool for skinning. It's called NG Skin Tools. It's a free plugin for skinning. It has its own good weight smoothing algorithms, and overall it's more convenient to use. I won't describe how it works. It's quite simple and pretty intuitive. Setting up the scales is a rather tedious and labor-intensive process, so I won't show you the whole character setup. The main thing is to understand the principle. I'll show again on the phalange of the finger how I usually do it. We can see that now the weights are too soft. The geometry is too weakly responsive to the rotation of the controller. Therefore, I select the points that belong to the phalange and apply to them 100% influence, or a weight that is equal to the one of the corresponding joint. After that, I smooth out the weights a bit. Something like this. Keep in mind that the weights can also be adjusted only on one side and displayed symmetrically on the other side with the mirror skin weights command. Here you can set the plane of symmetry, directions, and deformer associations. In my case, in principle, all values can be left by default. And you can see that the finger on the right hand behaves better. It's important to remember that the standard mirror skin weights tool should be applied when the character is in a neutral pose, in contrast to that NG Skin Tools plugin I mentioned earlier. You can also copy the weights from one object to another with the Copy Skin Weights command. Thus, objects can have different topology. This can be useful in situations when the topology of the character has to be changed, for some reason after the skin was set up, in order not to lose the work done. At the same time, the better the shape of both objects coincides, the better the weights will be transferred. I won't describe these options in detail now. I think you'll be able to figure it out on your own if necessary.